So Aditya Challapally will be our moderator. He's a machine learning engineering product lead at Microsoft. And he's also one of the instructors in the course Mastering GenAI for Product Innovation. And he will be moderating this session, asking a lot of questions to our two amazing speakers. So the first one is Emma Brunskill. She's the associate professor in the computer science department at Stanford. And her goal is to create AI systems that learn from few samples to robustly make good decisions motivated by applications, healthcare, and education. And the other speaker we have is Boris Cherny. He's coming to us from Anthropic. He's the member of the technical staff, and he is one of the creators of the Claude Code. So I'm sure that some of you are using it. Claude Code, I'm sorry, I'm mispronouncing it. Claude Code is Anthropic's AI-powered coding assistant that helps developers write, understand, and improve software more efficiently.
Thank you, Petra. And thank you to Boris and Emma both for joining us today. I mean, Petra obviously provided great bios, but just for everybody's sakes, especially when people watch this offline, I mean, both these are leaders in their field. Like Emma's a leader in reinforcement learning and AI alignment work, and obviously Claude Code is the frontier agentic software platform. And so we're going to ask them a bunch of questions today related to that work. As Petra said, feel free to ask questions yourself. So I guess to the both of you, and Boris, we'll start with you. Looking back, what was the first moment you felt like, wow, this technology is amazing, like it's really powerful in your own work?
I think for me, I felt it before Claude Code, actually. When I first started at Anthropic, I was putting up my first pull request. So it's sort of it's tradition on your first day, you start to ship code. And I was putting up my first pull request, and I started just writing it by hand, the way that I was used to before. And I was using like some IDE with some like AI integration. This is kind of the thing that I was used to. And I put up a request, and my spin-up buddy at the time, Adam Wolf, was like, and that's crazy. Because internally, we had this tool called Clyde, which is kind of like CLI Claude. And that was actually the other name that we were considering for Claude Code. And it was this like research tool that people wrote, and it was the predecessor to Claude Code. And the way it worked is you spin up this tool, you essentially pass in a bunch of flags, and you just tell it what you wanted to write. And it would explore the code base, it would make edits, and then you can kind of get it to make a commit for you. And I just couldn't believe that, a year ago or whatever, something like this would be possible. And so I tried it, and the same task that I just wrote manually, I gave it to Clyde. It wrote a pull request for me. It was perfect in one shot with like a little bit of prompting. And the tool is like, very hard to use, and there was a lot of rough edges, but I was just blown away that this was even possible, that like I didn't have to be the one that wrote the code, that a tool could do this for me. So yeah, that was a moment for me where I kind of became a believer that programming is fundamentally changing, and where we get to experience that and see that through.
Very cool. Boris, I guess a follow-up question for you is, in recent conversations and other sort of podcasts you've done, you've articulated that even when a model knows a correct answer, like productizing that knowledge requires overcoming challenges from both user interface design and feedback noise. Like I think you've expressed that before. And I think that's sort of related to like taking Clyde and turning it into Claude Code. How could you speak about a specific scenario or a set of situations for Claude Code where the path from model capability to reliable product behavior proved particularly difficult? Like what was the journey like turning Clyde into Claude Code essentially?
Yeah. I mean, this happens all the time, right? Like you see that the model is able to do something in training, or is particularly good at some evals, but then this doesn't actually match the feeling on the ground of when you use this model. And also the flip side, maybe an eval shows that the model isn't good at something and is actually really good at it. I think there's like one meta theme that comes up a lot, which is in like eval situations, there's no human in the loop. So, if the model does really well on a benchmark like SweBench or something, this is a situation where the model is essentially rewarded for completing the task without taking the time to get input from humans along the way. And this is very difficult. This is very different than the way that you use Claude Code day to day, because there is a human in the loop. And so, for example, if the model isn't sure what to do, it can always just ask a human kind of what's the right thing to do. Whereas in something like an eval situation, this is actually a really bad idea because it would mean the model doesn't solve the problem and so it doesn't get rewarded. So yeah, there's a lot of examples like this. There's also like sometimes the inverse where the model does something in a research scenario and then we get to learn from this and then we get to apply it to product. So a recent example was the models generally, they struggle at these kind of completeness tasks where there's a long list of things the model has to do. So for example, like I want you to run the type checker and then fix every single one of the type check issues. And, there might be like dozens or hundreds of issues. Just getting the model to reliably do this was kind of a struggle in the past. And they're okay at it, but they used to be much worse. And so initially we saw this as kind of a research problem where maybe like we weren't designing the tools correctly, or maybe there was just like something missing. And we actually like drew inspiration from what we saw in the learning environment, where we saw that on these kind of completeness tasks, the model started to make a to-do list for itself. And it would just write a file and it was just a kind of a markdown to-do list, and it used this to keep track of its work as it went. And we noticed that when the model did this, the performance was just much better. And so at the time we were experimenting with a bunch of different ideas on the product side. Like I had this idea of like kind of combinators for tools where the model could like make a bunch of tool calls and so on. There's a bunch of other ideas for kind of ways to prompt the model more heavily to do these tasks to completion. But actually it's funny, the thing that worked was just, it was at the time it was like a one-line prompt to just say, when you're working on a task that requires a lot of steps, make a to-do list for yourself. And that was it. And we just saw performance skyrocket for this series of tasks. And it's funny, I think that's kind of been the story of Claude Code, where the simple thing often works and the more complex thing often does not work.
Interesting. Okay, I want to follow up on that. I just want to quickly check. Emma, can you say something just to see if...
Is that working?
Yeah, it's working now. Okay, awesome. Working for us now. Okay. So we're gonna skip the previous question, Emma. But we're going to go right to what Boris is talking about now, which is, seeing instances where the model is hard to productionize and, really clever ways to figure out how to actually productionize it, I love that to-do list example. Have you seen anything like that, Emma, where you find it difficult? You found instances where model behavior doesn't necessarily come through?
Well, first of all, thank you all for having me. And I'm sorry about the AV. I always feel like the IT issues are the final frontier. If we can just get the LMs to solve that. So I missed a little bit about what Boris said, but I think it relates to this general challenge that we have certainly observed, which is getting the right alignment between what is the downstream behavior we want versus sort of what are the signals or optimization criteria that we're using in these settings. And that's definitely a challenge that we've encountered as well. And I think there is this trade-off. If I heard right, Boris, you were talking about sort of putting in additional feedback or structure that, whether Markdown or others or if we go back to sort of chain of thought reasoning, one of the early ideas, just how do we sort of structure and use maybe proxies or sort of short-term heuristics to get the type of output that we want? Versus being sort of more direct end to end and hoping that we can provide signals at the end that are sufficient. And so I think that is a big challenge. Many of you might know Goodhart's law, which is whenever we make a metric something we optimize, it ceases to be a good metric. And I think that's certainly been true in RLHF and other areas, that there are often really surprising ways to optimize the objectives we consider. And if we're not really careful with that can end up being a lot less effective than we would have hoped.
Oh, interesting.
There's kind of a practical, there's like a really practical example of this, which I think is something like I hit every day, which is like getting the model to write good unit tests. So if you wanted to generate good tests, essentially like the test needs to cover the code and then it needs to pass. Because if the model writes the test and it doesn't pass, this doesn't work. And so if you're doing reinforcement learning, you might imagine that you would reward the model for writing a test that passes. But then what happens is the model will do anything to get this thing to pass. It'll start like mocking everything out. It'll start hard coding stuff. In extreme situations where, if it's like really misaligned in some environment, it might just like delete your code. So like the test just passes because there's like nothing to test. And so I think this is also something that we saw in earlier models. So I think, for example, like Sonnet 3.7 really had this problem where it would mock way too much and it was very aggressive about it. And when you use the model, you really feel this, where it just wouldn't write good tests. And this is something we were able to fix with like the 4 series of models like Sonnet and Opus 4. And it's funny, like for me, not coming from a research background, like coming from a practitioner background, I think the thing that really made it click for me is back in December, my wife and I actually got a dog, and we're reading all these like dog training books about like how to train this thing. And we started noticing this behavior where we're trying to like teach the dog to come. And when the dog comes and he comes on command, then he gets a treat. And something the dog started doing is when we go on walks, he would just like stop and like sit somewhere and then just like look at us and just wait for the come command so that he could get the treat. And this is exactly the same kind of reward hacking that models tend to do. And I think this is this sort of like misalignment between you want to teach the model some kind of behavior, and so you give it a reward, but if you don't reward exactly the right way, then it teaches slightly the wrong behavior. And this sort of compounds and gives you, in the end, a product behavior, a user experience that you don't want.
Yeah, I'll build on that. I know one of the first examples that I'm familiar with of using reinforcement learning for education examples had this where the researchers, they were not trying to make a production ready system, but they were trying to reward the system for having the students be able to complete problems quickly. This was in around 2000, I think. It's a paper about 25 years ago. And so what the system learned to do was to provide really easy questions because students could get those right really quickly. And of course, that was not the long-term goal. And some of these examples I think are really obvious in retrospect, but when we start to optimize really complicated systems, it can be really hard to anticipate all of these reward hacking behaviors. And I personally found it quite interesting that now over the last couple of years, observing some of the work that Google's done on large language models for education, that some of the earlier work proposed more to do supervised fine-tuning and RLHF type approaches for optimizing. And then later it seemed like more of the work moved more towards sort of instruction following and trying to embed high-level pedagogical principles rather than using sort of direct closed loop optimization, in part because of these challenges. And so as an RL person, I'm very excited about being able to directly optimize objectives, but I think it is a really big research and practical question to make sure that we don't end up with the sort of reward hacking behavior that it does not provide value.
Oh, actually, there's a question coming in from Andrea, and it's actually relevant, very relevant to what you both are talking about, and honestly our next topic, which is specifically her question is, I've been thinking about how tricky it is to evaluate GenAI outputs when there's no right answer, like judging creativity. What's your take on building solid research methods, even when experts disagree on what constitutes a good result? Emma, do you want to take this first, and then we'll go to Boris?
Sure. I mean, I think that this is a really hard one. It's been coming up in some research that we've been doing as well, where we've been thinking about kind of insight creation, which can be a hard thing to define. I think, this comes up in many areas where there's not one single answer. I think from our perspective, we try to focus on defining one particular instance of this that we think is reasonable, maybe that a reasonable number of people might agree on, and then just be specific that this is one potential definition of creativity. It is not the only one, but can we mimic this sort of behavior, or can we induce this sort of behavior without claiming that it captures all of human creativity? And I feel like that allows us to still make progress without believing that we're solving the entire thing completely. But I'm curious to hear Boris's perspective on this as well.
Yeah. I think I agree with that. I mean, like when you're doing RL, there's like all sorts of different rewards that you can give, right? Like there's these kind of like objective reward functions where you can do something like ROHF, where you have like a preference model that's kind of a proxy for human preferences. So I think there's kind of a bunch of different methodologies for doing this, and yeah, like generally if you're trying to do something like creativity, it's pretty hard to objectively reward that. But typically, if you ask a person, is this creative or not, or is this good or not, then, people would tend to agree. Obviously, it's much harder if you're asking a question that even people don't agree on, because then it's very difficult to figure out how exactly do you reward the model.
Yeah, that makes a lot of sense. And I guess, we're going to come back to this topic, but we're getting a lot of questions about the future of software engineering. And, I know that's a topic both of you discussed. So I'd love to jump to that really quickly, and then we can come back to sort of feedback and training on that. But Boris, I guess we'll start with you, and then Emma, we're going to ask you this as well. But in multiple interviews, Boris, you've predicted that the future of programming will center more on reviewing and managing AI-generated code rather than direct manual coding. How do you see the skill set of developers evolving in this new AI-assisted era?
Yeah, in thinking about this, I tend to zoom out a little bit and think about how programming has changed over the decades, because programming has existed for a long time. Like, in some form it's existed, probably since the 1930s, like maybe like the Babbage machine or something like this, like even before that. So this is this thing that we do, like coding. This is a thing that's existed in some form for a long time, and over this time it's changed a lot in its form. Like programming of the past would be totally unrecognizable today. Like in the past, programming was you build physical circuits, and before circuits, maybe it was even like analog devices, some kind of like pressure-based way to transfer information and stuff. So it was like a very physical act. Even like the 1950s and 60s, it was still quite physical. You didn't code, you wrote punch cards, and punch cards were a physical thing that you used a physical machine to punch holes in this card in order to essentially write this software, which you then feed into another machine physically. And then the machine prints out its answer with a teletype machine on paper. So this is also like a very viscerally physical act. And at some point, this started to become software. So the code itself became encoded to software, and the act of programming, it stopped being this thing where you're physically programming a device, and that also moved into software. So you started to see text editors. Like I think like the Ed text editor, which is still installed on everyone's MacBook. You can still run the ED. This was invented in, I think, like 1967. So programming has been kind of changing in this way for a long time. And as an engineer, the thing that you do has also been changing. So before it was designing circuits, then punching punch cards, then ones and zeros, then assembly, so kind of like low-level language. Then it was programming higher level languages like Fortran and COBOL. Then eventually this moved to Java. Then even higher level like Python and JavaScript and Haskell and things like this. And so I think that this will continue to change, and I kind of view it as something that is on this continuum, but it's also not a linear process. I view it as an exponential process that we're sort of in the beginnings of right now. And I think what the parts of this that we've started to see is that instead of directly manipulating source code, as engineers, what we're doing now is we're prompting agents, and then we're manipulating these agentic transcripts. And this is where programming is becoming, and this is what most of my programming is day to day. And I think that verification is sort of the next thing to change. So, internally at Anthropic, Claude does most of our code reviews today. And this is something that many customers use Claude Code for, is to just do code reviews for them. And I think we're already getting to this point where Claude can generate code that is likely correct much faster than a human can review it. And so I think one element of it is, can you also use automation to reduce the cost of code review? The second part is, can you improve model alignment and capabilities to essentially raise the floor so the code is more likely to be correct? So the downside of an incorrect review is not as bad. And then I think the third thing is, can you use Claude to like literally automate this? So like actually have Claude do the code review, have Claude managing other Claudes, and have essentially, I think nowadays people are calling these like agentic swarms. So like a lot of stuff in AI, there's a lot of like hyperbole in the terms that people use. But yeah, it's like the idea is like, can you just have like a multiplayer Claude system? And I think we're kind of in the beginnings of seeing what this is right now. And I think very likely by the end of the year, there's gonna be some versions of this that the companies are adopting pretty heavily.
Emma, I want to ask you that same exact question. I want to ask a quick follow-up to Boris, because you mentioned that, Claude Code could generate code faster than humans can review. And then Claude Code can also review those changes or those PRs and then suggest changes, and then it's like a cycle. I guess what I think what people are thinking now is, if this is like a fully closed agentic system, what skill does a developer need to have here? And potentially that means that, non-developers can be just as productive as developers, and they just need to give the idea and it executes by itself. But what do you think about that?
I think in today's world, the skills are, you still have to know how to code. So you still have to understand the language, and you still have to understand system design. and architecture and things like this. There's these new skills you have to know in addition, which is like prompting and context management. Something that we see is that the quality of the prompt has obviously a giant impact on the quality of the result. And so learning to prompt well matters a lot. I think there's this kind of meta skill that's developing right now, which is building agents. And what is an agent? It's just a prompt. It's just, Claude Code running with a custom prompt. And so like writing that prompt also to kind of do this like meta level of engineering to create this thing that can then do code review, or that can then, help write code or simplify code or whatever you want this agent to do. This is the next skill. I think in this industry, it's a little hard to predict more than a few months out. But I think this is where we are today.
Awesome. And then Emma, that whole set of questions at you.
Yeah, well, I mean, Boris knows a lot better than me sort of on the ground. I guess I'll just add on to that. I think it is a really interesting question. I totally agree with everything that Boris is saying about the direction and where things may be changing in the future. And I expect too that prompt design will also continue to be more automated, and that it's more and more possible to have agents also create good prompts for one could be more and more agnostic to the human's prompt in terms of designing the type of systems we want. But on the other hand, I think that it will continue to be important for at least some people to really understand the full stack of details. And the way that I often like to think about this is most of us have microwaves in our house. Most people do not actually understand the physics of how microwaves work, but they can still use them to, reheat food and use them in their day-to-day life. There are only some of us that know how to fix the microwave when it breaks, and there are even fewer of us that could invent the next microwave. And I think that we will continue to need people that can both, really understand the system and so fix microwaves or, fix or identify the basic flaws in these systems, as well as invent the new frontiers. And it is not at all clear to me, and I think probably to most of the community, what that means in terms of the basic knowledge people need to accomplish that. So do we have to go all the way down to sort of transform our understanding in order to be able to invent the next version of Claude Code or to be able to understand when it's going wrong? Or can we start at a much higher level of abstraction? I think that's something from an education perspective is just not clear yet. I mean, it's something that we'll be sort of trying to rapidly evolve to. But I will note that at least I also do quite a lot of theoretical work with my lab, and it is certainly the case that the systems still continue to make lots of mistakes. And so there are cases where, just as what Boris is saying, if you're a good coder, you can detect perhaps if it's sort of hacking and creating test cases that are not really valid test cases. If one's a theoretician, you can understand sometimes if it's not doing the theory correctly. And so that does still require monitoring and skills to be able to identify that. And so I think the big question is, how far down in the stack do we need people to go in order to be able to identify that these systems are robustly creating this, the sorts of solutions we want, and then be able to make the next step forward?
There's this interesting parallel that Emma that you're reminding me of is like, in computational complexity theory, we talk about like some tasks being easy to compute and easy to verify. Other tasks are easy to compute, hard to verify. It's kind of weird, but usually it's hard to compute, easy to verify, or kind of hard to compute, hard to verify. You can kind of partition tasks into this sort of matrix. And I wonder if it's kind of similar here, because something that I often see is if you use a system like Claude Code to learn about the code base, so not to write code, but to explain how does something work, or like how does this subsystem work, or what is the history of the system, why is it designed this way? The answers are actually like exceptional most of the time, and better than what an engineer would have said. Because this just involves reading code. It doesn't involve producing code. But if you ask that same system to write code for you, it won't be as good. So I think like where today's models are at is if you have a really good coding agent and you use it for code understanding, it's probably like a 9 out of 10 experience, or maybe even a 10 out of 10. It just gives really great explanations a lot. And this is also something we're starting to see at Anthropic, where we teach Claude Code to people when they onboard. You learned this in, I think, the first or second day of technical onboarding. And now onboarding onto an engineering team now takes like 2 or 3 days, where before it took weeks, because you just ask the system any questions that you have. You don't have to ask other engineers. And so I wonder if maybe these things are kind of two different things, and we can maybe think about it in a matrix, or kind of as kind of like different kinds of tasks. So just explaining code versus actually producing code.
It makes a lot of Go ahead, Emma.
I was just going to say, I think that also, to me, resonates with my experience and what I've seen in the field, like the research field, of the fact that often LLMs as judges are pretty good and can be used to then, in closed loop, sort of optimize the generation capability as well. Because at least in some cases, even less good models are able to give sufficient critiques that they can improve their original system. And I agree also sort of in terms of speed of learning and speed of uptake, the ability to have sort of unfettered access to a very good explainer when one's onboarding in a new area is incredible, and I think can really speed how quickly we could learn, whether it's Claude Code or anything else.
Mm-hmm. And back to microwaves, maybe it's like, not everyone has to be a microwave like technician or engineer or whatever, but maybe if a model can just tell your microwave breaks, but a model can guide you through how to fix it pretty well, maybe that actually serves a lot of the use case. I do think there's also this kind of parallel to coding where, like, this microwave example is really good. I might start using this one if that's okay. I think there might be this parallel where I think we're in this moment right now where coding is about to open up to a lot more people, because you don't have to be a systems expert anymore to write code, and you don't have to know the languages and the tool chains really well. And I think this is hugely empowering, and we haven't yet figured out what this means. But yeah, a lot more people are about to be able to start writing software.
Yeah. I have two thoughts on that, actually, which I think are very interesting to your points. It's like, I think in terms of using LLM as a judge versus LLM as a creator, the way I think about it, or the way I explain it to folks, is I think it's very easy to judge if a movie's good or bad, but it's really hard to make a really good movie. And so I think, like, you can train an LLM to actually judge if something is really good or bad, like just as a human can. But like, not everybody can be a director. And the other side is, in terms of, and the question I think we often get, I'm sure both of you often get it as well, is, is there even any point in being a developer anymore? Like, is there any point in learning code? And, it seems like both of you would agree, but I'd love to ask again. But the way I think about it, or the way we think about it, is there's still so much code left to be written in the world. Like, we've still so many unsolved problems. And if you think of code as a way to extend human ability to solve, major medical issues, or to take us to the moon, or take us to the Mars, or, expand the solar system travel possibilities, then code is the way to get there. And, we've not even scratched that surface. But, I guess, so to be clear, and I want to make sure we ask this again, because again, I would say at least like half of the questions we're getting are just about this. So you would still recommend, I guess, to both of you, you would still recommend learning how to code and learning system architecture and all of those details? I guess, Boris, we'll start with you, because you mentioned it.
Yeah, definitely. I think at some point you won't need to. We're not there yet. I think we will be pretty soon. But I think for kind of the generation of students today, you're sort of in this, I think, tough spot where you don't just have to learn the old thing. You don't just have to learn the new thing. You actually have to learn both, because the new thing works pretty well, but it's still imperfect. And so you have to drop down to the kind of the layer of abstraction under it fairly often. So yeah, I would recommend still learn coding, learn programming, learn the languages, learn system design, learn frameworks. But also you have to learn all the new tools, and you have to learn how to prompt, and how to use context, and how to build agents, and this new tool set too.
Cool. Anything to add to that, Emma? Or I'd love to get to the other RL questions and the other product feedback questions as well, but unless you have anything to add to that.
I would defer to Boris on this. I think it's a really hard question. I think that right now, it's certainly still valuable to know how to code. I expect that to continue to be beneficial for a while. I think that things like a prompt engineering job, I don't think that's going to exist long term. I think that's going to go away, and probably pretty quickly. But I think that being able to learn how to code and generally learn how to do things quickly and pivot and be able to learn new skills, that's going to continue to be really helpful. I mean, like Boris said, what it means to program has changed enormously over the last 70 years, and what it means to be a computer scientist. And we expect that to continue and probably to accelerate. So being able to pick up on new skills as well as learning the previous ones in itself will be helpful as the field pivots.
Awesome. And I think that's a great way to wrap that up. So I'd love to move to our third topic, which is around RL for you, Emma, and then product feedback and design for Boris. But Emma, we just got a question, which I'd rather use, is what is the current bottleneck with RL or just alignment in general? All the policies seem so brittle, sample inefficient, and slow to generalize, et cetera. So where are we at the current state of alignment in RL at a high level, you think?
Oh, well, it's a great question. It's a really hard one. I mean, I think that's very broad. I think it really depends what we want from systems, right? So I think that when you have a verifier possible, and what I mean by that is like if you can have unit tests, or if you can have a theorem prover, or if you can have something which is really a ground truth signal of whether or not what you've output is correct or not, or whether it's good, I think we're in pretty good shape. In those cases, some of you might be familiar with the results from DeepMind, where a long time ago, well, about I guess a decade ago, they had human level or beyond human level performance in the board game Go. Recently, they've had results showing that they can place in the gold level for the Math Olympiad, which is for extremely good high school math students. And so those are domains, and I think coding will fall into this too, mostly, that where we can often have a verifier and we can tell whether or not the solutions are correct. And in that case, there's a lot of really great work in reinforcement learning and multi-carload research and things like that, which means that I think we can there already has been enormous progress, and there will continue to be. I think for some other areas where we don't have great simulators and we don't have great verifiers, it is still very open about how to use these systems to make a lot of progress. So if we think about using them in the context of healthcare or education, or things that might have very long time horizons, like helping develop someone to become a manager or things like that, I think that there's a lot of open questions about how we could have RL that is very many multi-steps, deals with very sparse and nebulous rewards, is very data inefficient, or is very data limited. Data augmentation and simulation help, but we typically don't have great models of human behavior inside of these. It's known, we do some work on behavior change and supporting people on things like learning to assist people with mental health and helping, and also separately helping people with their fitness goals. And in those cases, when we think about human behavior change, the models that LLMs provide are often not very good. They often change way too fast, and they're way, maybe sometimes slightly sycophantic to suggestions. And so I think those cases where we're data limited and we don't have very good simulators, there's still a long way to go for RL. But if you do have a setting where you have a good verifier and a reward signal and you can simulate the system, I think there's a lot that's already been done, a lot that could be done.
And I guess, Boris, an analog question to you is, you've stressed again in other podcasts that product feedback needs to be actionable. And often you get a lot of, especially with something like Claude Code, there can be a lot of noise, but you need actionable feedback to drive sustained improvement. So what have you learned about designing feedback or instrumentation collection methods that promote genuine product progress rather than short-term noise?
I think the most important thing has been to give the team as raw access to feedback as possible from users. And so I think typically what you see when people build product is by the time customer feedback makes it to the product team, it's gone through like 3 or 4 layers of filtering where it's been summarized. And at the end, you get this kind of like somewhat biased, maybe nugget of feedback from the end user. I think for our team, we actually try not to do that. So we try to make sure everyone on the team talks to customers. Obviously, everyone uses the product every day, directly addresses feedback and so on. So you kind of let every engineer on the team form their own kind of mental model of what it is that the customer wants and what that feedback is. I think like maybe to zoom out, I think generally the task when you're trying to get user feedback is 2 things. It's to understand what does the model want and what does the user want. And understanding what the model wants is this really new thing. Like this wasn't a thing before, but with LLMs, this matters a lot because if you don't understand what the model wants, you can't build a good product. And you're going to build things that are at odds with what the model wants all the time, and it just won't work well. For users, I think that actually the best way to figure out what users want is not to ask them, and it's not to wait for their feedback to come in. There's two particular methodologies that I really like. One is just watching users work. So my favorite kind of thing to do is like get volunteers and just watch them use Claude Code for like an hour, and I'll just watch over their shoulder, and I won't ask any questions, but I'll kind of take notes about all the stuff that's not working. And this is kind of in user research, this is called an observational study. And every time I'll come up with just pages and pages of notes. It's just incredible how much you learn by watching people use the product, because they're going to use it in all these ways you didn't expect. And, it's going to be incredibly frustrating because they're going to be stuck on something. You're like, oh my God, we have a feature exactly for this, but you can't tell them because you have to see how they get stuck and how they kind of get unblocked. And then I think the other methodology to figure out what users want is this idea called latent demand. And I think this is one of the most powerful ideas in product development that I've learned. And I actually picked this up at Meta when I was there for a while. And it's this idea that you build the product in a way such that users can hack it. And they can abuse the product in a way that it was not designed for. And then you see how people abuse the product, and then you design a product feature for that. And so, one example from like a different domain is Facebook Marketplace was built based on the observation that at the time, 40% of posts in Facebook groups were buying and selling things. And so Facebook groups was this kind of like very general product, and the idea was, okay, people are kind of hacking it to do this thing that it wasn't really designed for, so maybe we should just build a product for that. And then obviously Marketplace was a big success. Facebook Dating, I think, was another good example where I think this is now the biggest dating product in the world, if I remember that right. And it was based on the observation that 60% of people viewing other people's profiles on Facebook was people that were not friends with each other and were the opposite gender. So kind of this kind of like a traditional kind of dating setup. And so obviously this means that people have this intent. And so if you can kind of harness that with a product, then it works. And so this is very intentionally how we built Claude Code. Is we build it in a way that can be hackable and that you can customize, and that is very general. So we're very unopinionated about the way to use it. And we just watch how people use it. We fix issues, and then sometimes we build product features around that to better enable the behavior.
I love that. That's like, and actually before I ask a follow-up, I think it's very important because you mentioned that you now have to consider what models want. I think that's incredibly important. Can you define for everybody what you mean by that? Especially, I think that's an extremely fascinating and new field.
Yeah. So one example is, I guess to zoom out a little bit, if you look at how people are building applications using LLMs, I think there's kind of two philosophies. One philosophy is you have this idea in mind of a product you want to build, and the LLM is some component of that. And then you put the LLM behind some kind of API or something where you interact with the LLM the way that you need. The other philosophy is you watch the thing that LLM is trying to do, and then you let it, you enable that, and you support the LLM trying to do that. So like one very like particular example is like, let's say every time the model writes code, you want it to also run a linter and then fix any lint issues. And one thing that you can do is you can kind of like ask the model to do this, and it might do it sometimes. And then you can kind of arm twist it into doing this. So you can kind of maybe at every user turn, every time the model does something, you can always remind it. Remember, after you're done editing, you must run the linter. Or maybe every time the model edits a file, you can add a reminder there. And it'll kind of do this most of the time. But then at some point, what will happen is generally, if the model isn't trying to do this thing and then you force it to do it, then you're kind of knocking it off of distribution a little bit. So now like the distribution of data it's seeing in the wild does not match the distribution it's on training. And so it'll start to get like a little wonky. And you're going to see intelligence kind of subtly degrade over the course of that conversation. Instead, what you could do is you can give the linter as a tool to the model, and you can just prompt it and say, hey, model, you have this tool that you can use. If you like, you're free to use it. And you're going to see the model kind of naturally use the linter when it needs to in order to improve the quality of its code and get the result that it wants. And generally, the second approach gives way better results. And for anyone building on LMs, this is generally what we recommend.
Any thoughts on that, Emma? That's fascinating.
Nope.
Okay.
That was very
I guess, Boris, to that point, do you have, about this feedback about instead of prompting every single time for it to use the linter, and instead have it use the tool that does linting or lints for you, is there I guess, are there other resources, or has Claude or Anthropic published any resources for folks to understand how to do this prompt engineering really well?
I think there was like an article about building agents that came from Eric Schwanz and I think Barry Zhang. That was really excellent. Yeah, I think generally just don't try to overbuild, like start simple, see what the model is trying to do, and then just help it do that thing. It's very similar in my mind to kind of this latent demand idea for users, to kind of see what the user is actually trying to do, and then build for that.
Fascinating. Like you naturally see like the model's behavior and you try to map to it as much as possible to achieve your goals, rather than just try to like align it every time.
Exactly. And if you try to kind of micro steer it to kind of make the model do everything you want in the tiniest ways, you're going to get bad results. It's the same as a human, right? Like if you're a manager and you have an employee, and you try to kind of make them do everything that you want in the kind of the most micro sense, they're going to be like, you're a terrible manager because you're micromanaging me. And you're not going to get the result you want because they're not motivated now. And it's weirdly similar to the way that a model works, is just give it a high level goal and then give it the tools that it needs to get there along the way.
I love that.
So we shouldn't micromanage our LLMs.
Wow. I mean, I love it. Actually, and this brings us to, I think, a really important question as well, which is, and this is to both of you, but we'll start with Boris, is, I guess, drawing from your unique experience of building something that has probably been like one of the defining products in this new LLM space. What's a foundational principle or mindset you believe will be critical for the next wave of GenAI builders to adopt? Like, is it the latent demand piece? Is it like watching users? Is it like, what's the mindset in general that people should adopt, do you think, that they haven't yet?
Yeah, I think in addition to these things that I've talked about, one other thing I would suggest is don't build for models of today. And instead, try to forecast where models will be 6 months from now and build for that. And generally, if you are building a thing and you kind of hit this frontier of model intelligence, so maybe the model is not reliably succeeding at the given task, or maybe it's succeeding maybe 20% of the time or whatever, you can usually augment this with a bit of scaffolding. So you write a program outside of the model that helps it with this task. Maybe it breaks it down or gives it some tools or whatever, maybe like structures it a little bit. And then as the model improves, usually you can just delete the scaffolding. And so like an example of this is Claude Code. I think it really started to work well as a product when the 4 series of models came out, like Sonnet 4 and Opus 4. Before that, it was like, okay. I think it got really good when those models came out. And I remember in the weeks leading up to the launch, we actually like deleted most of the system prompt that we needed for 3.7. We also deleted a bunch of the tools that it had just because the model didn't need it. So you can kind of see even the prompt as a form of scaffolding in this world. And so we were able to build this product that was not quite ready because the model wasn't quite ready. And then when the model was ready, we could adjust very quickly. So that's what I would recommend.
Emma, any thoughts on that?
No, just that aligns with what I've heard with a lot of other people saying, like the base capabilities of the models are getting so much better that often instead of kind of doing a lot of additional scaffolding to make it work for a particular task, often a lot of that will become obsolete later as the models get better.
Yeah. And I guess quick question, Boris, as much as, I mean, how should somebody think about where the models would end up in 6 months? Like, let me give you a random example. Like, let's say there's a startup or something focusing on, I don't know, like PNG to SVG conversion. They're like making extra models just for that. Maybe in 6 months, like Claude Code or Claude can do that by itself with no scaffolding. Like, how would you, I mean, it's like a $1 trillion question, so it's a hard question to answer, but do you have any thoughts on how somebody would even think about guessing that?
Yeah, I'm actually really curious what Emma would think about this, because I think this is more of a research question about kind of seeing where the model struggles in training.
Yeah, I think it's a great question. My sense, though, is that because most of the major model advances are closed, that it's hard to anticipate that. I do think that I think it's sort of I think there's like this interesting double-edged sword. I'd be curious Boris's thought on this as well. On the one hand, I think that like large companies like Anthropic and OpenAI and DeepSeek and lots of other places that are putting a lot of resources into this can build models that are incredible, and very small teams may find it very hard to compete with that. And so therefore it's hard to have visibility, and there's a lot of potential that people's innovations will just get superseded. On the other hand, I think that DeepSeek and others have suggested that the runway to get to extremely good performance is much shorter than expected. And I think that the moat is not very large. So on the other hand, I think small teams and organizations could potentially be competitive quite quickly. But I think my main thought there is that rather than doing things that are very specialized and niche, that it makes more sense to focus on broad capabilities. I think potentially one exception to that might be if people have very specific data sets that they know are not publicly available. And again, I'll go back to say healthcare as an example. Those are ones that I think often, and it's changing, everything is moving, like lots of organizations also are starting to partner with healthcare organizations. But I think that sort of data does enable different types of applications, which may be harder to see in sort of general frontier models for a while.
Yeah, I think there's maybe like a product analog that I can speak to, which is Claude Code. It started with just me, and it was just me for many months before we kind of grew the team and kind of added folks to it. And it's built on the public API that Anthropic offers to everyone, and it uses the same models that we offer to everyone. So there's actually like nothing secret on like the research or anything different on the research side or inference or anything like this. So this very well could have been a product that was built by one person externally, the same way that it was kind of built by one person internally. And I think this is now this kind of magic moment where there's so many of these opportunities. And I can't really speak to it as much on the training side. This is Emma's domain. But I definitely in the product side, this is the moment where a single person can build these products where before it would take a large team to do it.
Interesting. And I guess in our last few minutes here, Emma, I'd love to ask you a few more questions about where you think talk about this future of AI. Like, forget about I guess 6 months from now. I think you talked about this a bit publicly and in your lectures as well. Like, where do you think AI will be like fast forward 10 years from now? Like, if things go really well, what does life with AI look like, you think?
I think that is a very hard question to answer. I guess I'll talk more about where I hope things will go rather than where I know whether things will go that way.
Right, yes.
I think I'm really excited about the potential of human augmentation. And there's an MIT economist called David Otter that had a really interesting paper over the last couple of years. And one of the things that he said in it was that replicating our existing capabilities simply at greater speed and lower cost is a minor achievement. The most valuable tools complement human capabilities and open new frontiers of possibility. And I really love that quote because I think that, if we went back 2,000 years and we somehow managed to make horse-drawn carts available to everybody, or that everyone could have a robot that waved incense, it's not clear that we would have the sort of life expectancy and go to the moon in the way that we have seen as possible. And so to me, the most exciting thing is what are the new areas of human inquiry and the new advancements that will be possible with these tools. Will we be able to cure cancer? Will we be able to completely change human lifespan? Will we be able to have vastly more, people living out of poverty, vastly more people able to achieve their potential and have dignified, exciting work? Those sort of things to me are extremely exciting. And I think a lot of the focus is often on replicating human capability, but tools like Claude Code and others, these all have the enormous potential as well to augment. And as Boris was saying, many more people now will be able to write code for all sorts of application areas who may not have any training in these areas, and they will often have very exciting new types of places where coding and computer science and programming and in general computational tools could be incredibly impactful. And so to me, the most exciting thing to think about in sort of 10 years is what are the new frontiers? Will we have done something equivalent to going to the moon in ways or, that we can't envision yet? And I think that will be a truly transformative moment for humanity if we achieve that.
Is there any one of those that you're particularly excited about that, you think you think like is like either personally close to you or you think would be excited, for others to build? I specifically ask a lot of there's some questions in the chat specifically asking what you would be excited about personally.
Yeah, I mean, I think to me, the thing that I am both, so I try to be, there's some evidence that it is actually provably optimal to be an optimist. So I try to follow, the research in that case. I think the thing that I am both really excited about, but also concerned is that I think we're going to have a really major transformation, or I think there's a very good chance we'll have a very major transformation in economy due to AI. And historically, we have tended to be, outside of wartime, very bad at retraining people. I think actually wartime is a pretty interesting time to look at because often we manage really not going to be facing like an alien threat anytime soon and are hopefully not going to be in major world wars. Historically, we've been very bad about retraining people, particularly those that are outside of formal schooling. And so I'm really hopeful that we'll figure out ways to make it so that people can continue to have dignified, exciting work throughout their lifespan, which I think will involve envisioning all sorts of new ways of doing continual lifelong training and job support throughout people's lives, not K through 12 or maybe K through 16, but like K through 85, but how are we going to envision these new forms of what it means to work, what it means to have a long, exciting, fulfilling life when sort of the modes of production and the things that are possible are going to be changing so fast. I mean, on the one hand, it is completely incredible now that one person could do something like Claude Code and of course, expand the team overall. On the other hand, what does that mean in terms of employment? Maybe we will all be our own CEOs and we'll all have lots of startups and there'll be amazing marketplaces for sharing the inventions we create. But I think it's a really transformative time for us to get that right.
Awesome. Boris, any closing thoughts on that or any closing thoughts in general?
Yeah, I think this is kind of the optimistic future that also really excited to get to. I think to get there, there are many, many challenges that we're going to have to navigate. And I think these are kind of things like, like the changing nature of human labor and kind of the stuff that Emma talked about. But there's also kind of even more near-term stuff. Like, the latest LMs are excellent at hacking and, like finding like zero-day vulnerabilities. It's like, what does this mean? And I think we need to like look at this as a society to figure out, do we want to regulate this? If so, how? What kind of limits do we want to place on this? What do we do about this? I think also similarly, we started to see this with Opus 4 when we released it back in March. These things are pretty good at designing like synthetic bioviruses. And this is something where AI labs have a responsibility to make sure that this technology doesn't get into the right hands and that we essentially hobble the model's ability to do these really bad things. But I think also as a society, this is something that we're going to have to increasingly navigate as like the model's capability to do things that are very dangerous for humanity as this increases. And, it's only going to increase from here on out. So same as Emma, very excited for this optimistic future. And I think we'll get there. But to get there, we have to navigate these really, really hard challenges. And this is something we have to do as a society.
I guess maybe I could just add, just to build on what Boris and I were just saying, is that I think sometimes the way things are presented, and maybe I'm biased because of Silicon Valley, but like that is that this is going to be inevitable. And I just want to sort of encourage everybody on the call that these are all choices for us to make. None of this is written. And so we can really choose the society, both locally and globally, that we want to occur with these systems. And so I feel like whether it's on the regulation side or building the models themselves, we have a lot of agency. It is not already determined, and so we should really leverage that agency in creating the type of future we want to see.
Absolutely.
Exactly. Awesome. Petra?
Yeah, thank you so much. It was really great hearing from both Emma and Boris on the thoughts about the subject. So thank you so much for making the time. I know you both are super busy with everything that is going on right now. Aditya, thank you so much for moderating. If people are interested in rewatching this, kind of reviewing some of the thoughts that have been mentioned, we will be posting the recording on YouTube, and also we will share the recording with you kind of if you sign up for the webinar. And if we didn't get to your question, we apologize. We try to get to as many as we can, but we also had some kind of prepare before, so we try to also get to them. But I appreciate everyone's time. Have a wonderful rest of your day.
Thanks for having us. It was so fun.
Thank you.